Okay, I already started recording, so we're still talking about chapter 16. This is the last chapter, which is a sheet metal working. And as we said last time, sheet metal working, the cutting, bending, and drawing. This is a cutting, this is a cutting, this is a bending and drawing. We'll take it one by one. We'll discuss it one by one. Start first with the cutting. And this is the sheet metal cutting 16.1. A cutting actually cutting is preparing or cut the sheet with the required size. I mean, the word cutting is to cut the sheet with the required size for another sheet metal processing. The cutting here is a shearing. The cutting here is another meaning of the cutting is shearing the material. So shearing mean we have here, as we also discussed last time or said last time, punch and die. This is a tool. We have punch and die. This is a tool for cutting, and this is a sheet. And then punch approach step by step. I mean, cutting step by step. It happened. This is a punch. This is a die. Punch approach. Punch here approach. As you can see here, permanent deformation will happen. Plastic deformation initially. First step, plastic deformation will happen. Punch approach more increase. More permanent deformation, and at this point, crack initiated. Crack initiated here, and then crack propagated, and finally punch will separate the part, then part will be separated. So shearing here, you see this cutting and shearing, you shearing the material, part will be separated, then sheet here is cutting or part will be separated. This is a process from beginning to the end, or the cutting process from beginning to the end. And when we have a cutting, this is an example of the cutting. This is an example of the cutting. This is a bunch. This is a die. This is a die. This is a bunch. And the bunch here come to cut part of the material. So this is a sheet. This is a sheet. And here bunch cutting part of the material. Okay, very good. So bunch cutting part of the material. This part is cut, right, from the sheet. Right. So when you look to this edge, when you look to this edge, which is this edge, there are two edges. One edge is here, one edge is here, this one. One edge is here, remaining part, which is this one here. You can see there are several area or zone. Here we call it is a rollover. This one we call burnish. This one we call it fracture zone. This is a bar. Rollover is a permanent deformation. You can realize that rollover here is a permanent deformation. Initially, when the bunch starts the process, the permanent deformation happens. So this is whatever we call rollover. Burnish here, the bunch here wrapping surface, and this one is very good. I mean, it is very good quality. This is a burnish, and then fraction zone. Here is crack initiated and propagated. This part is very rough. Fraction zone here is very rough area. And this is the part here, separation done here. This is a permanent deformation. From beginning to here is a permanent deformation. And here is a crack initiated and propagated to fraction. And then fraction happen here. We call it fraction zone. And this is a bar. The bar is part of the material is remaining, extra material remaining. This mainly because of the elastic properties of the material. Material have some elasticity, so when a punch is moving, then material will move with the punch, but a little elasticity remaining keep extra material attached with the work, but we call it is a bar. Details of this kind of rollover and burnish and fraction zone and bar is written here, and you can read it, right? Okay, so shearing, when you come to the shearing process, generally when you say shearing process, this is a shearing process. This is a bar, this is a punch, and this is a die. The punch will come to cut the die here. The punch will come to cut the die. This is the front view, this is the side view. Mainly to shearing the part here to cut a smaller part for subsequent process. I mean, maybe big sheet you cut is to smaller sheet, and this one required for another process, and so on. The machine that used, we call it is a power shear or squaring shear. The machine used for shearing, we call it is a power shear or squaring shear. And here you can see that the blade or the punch blade is not straight, but it is whatever we call is inclined. The blade is inclined. Why blade is inclined? Blade is inclined so the force will increase gradually. This blade will start here the process. It will contact initially at this point, and then gradually more point will contact. I mean force will increase gradually. So usually punch is inclined, as you can see here. This is mainly technically needed to increase the force gradually in the shearing process. Listen to me carefully here. Shearing process is the two main operation. We call it planking and bunching. Planking and bunching. Let me say this is a planking operation and this is a bunching operation. What is the big difference between planking and bunching? This is really important. Planking, when you said planking, you make plank. Let me highlight this one. When I said planking, you make plank. You make plank. The word blanking, you make plank. But bunching create hole. Create hole. Someone said that, okay, you create plank, meaning you create hole. No, no. My target is a plank. This is my target. When I said planking, this is a scrap. I don't want this one. This is the initial part. This initial sheet. I cut part of the sheet. This is my target. So planking is to create plank. This is my part. This one is a scrap. I don't want it. Regardless hole, not hole, this is not issue. I'm not concerning about this one. I'm concerning about the plank. This is what I need. So the word planking is to create a plank. This one is scrap. The word bunching is opposite. I would like to create a hole. I need a hole. This is my part. I just would like to create a hole. This guy here is scrap. I'm not concerning about this one. We call it is a slug. We call it also, this one is scrap. We call it is a slug. So we call it as a slug. This slug, I'm not concerning about this one. I'm not concerning. Let me just write here. Let me highlight this one. I'm not concerning about this one here. This one, I'm not concerning about this one. So in first case planking, I'm focusing on the plank. In second case punching, I would like to get just a hole. This is my part. I just would like to create hole. Regardless, hole is square part, is circular part, it doesn't matter. I'd like to create hole. This one is scrap. Did you get the idea? Did you get the difference between planking and bunch? This is the two process, generally two process in shearing. In a shearing process, very important to fix or to adjust the clearance. Clearance, what clearance? Clearance actually is a difference between diameter of the punch and diameter of the die. This is a punch diameter, right? This is a die diameter. Finally, punch will move inside to cut. Punch will cut here. Punch will cut here, right? Then punch will get inside. Then diameter, listen to me carefully. Punch of the diameter must be smaller than a punch of the die. You agree with me? Because the punch, the diameter of the punch, if the punch bigger than the diameter of the die, how to cut? No way. Then a punch diameter must be smaller than the die diameter. This is a die diameter, then this is a punch diameter. How much, how big it is? I mean the big difference between the die and punch diameter. This whatever we call clearance. So the clearance here is the difference between the punch diameter and the die diameter. This is the clearance, right? This is a big view. This is focus here. This is a big view. This is diameter of the punch, this is the diameter of the die. Can you realize this is the clearance, right? How big the clearance, how small the clearance, how we can adjust the clearance. They said that if clearance is very small, if the clearance is very tight, as you can see here in this case, very high force will be required. The force required to do the punching will be very, very high. If the clearance is very big, this one is very small. If the clearance is very big, then you damage the workpiece. Tearing happen, not shearing, but tearing. Tearing, you destroy the workpiece and we get big distortion in the workpiece. So we avoid having very big clearance and we avoid having very small clearance. Clearance must be adjusted in between. So this one is a correct clearance in between to have a good and nice shearing process for cutting. Someone will ask me, what is that in between? What is that in between? Actually, they said that it is recommended, a clearance here, which is this one, clearance should be within 4 to 8% of the thickness. 4 to 8% of the thickness. What thickness? Workpiece thickness, sheet thickness. Whatever thickness you have, this one should be within 4 to 8% of the clearance. This one experimentally investigated, right? So this is a recommendation. Below this one, 4 to 8, you get tight clearance. Bigger than this one, you get big clearance and you get distortion in a workpiece. This is the clearance effect. Then you have to keep clearance within the range. You understand? It's written here. I put here for you. So here, I told you that it is written here actually, between 4 to 8% of the sheet metal thickness. This is a recommended clearance. So recommended clearance should be within 4 to 8% of the sheet metal thickness. This is a sheet thickness we have to keep in this range. Okay, then clearance actually can be calculated, can be fixed at different processes. The clearance equal to clearance is this one. Clearance is this. This is a clearance, right? This is a clearance. This is a clearance. Clearance between the difference between the die diameter and punch diameter. This is the difference between die diameter and punch diameter is 2C, not 1C, because we have one clearance here, one clearance here. So die diameter minus punch diameter is not C but 2C, 1C here and 1C here. Then C can be obtained as AC multiplied by T. What is the AC? AC, we call it allowance, and T is the thickness. What thickness is the workpiece thickness? Sheet thickness. AC is the allowance. Allowance is at different processes. For shearing aluminium alloys, tempered to a certain grade, cold rolled steel is different here. You can see that this kind of AC has different value for different material. If you're cutting aluminium alloy or shearing aluminium alloy, if you're shearing aluminium alloy tempered certain grade, cold rolled steel and other material, AC value have certain condition. Still within 4 to 8% of the thickness of the workpiece. However, it is can be obtained as a certain value. Here is an AC can be obtained as a certain value. If you multiply by thickness, you get the C. Then you get the difference between two diameter is 2C. So this one can be obtained as you can see here, right? Please give me your attention. Please give me your attention how to identify the diameter of the die and diameter of the punch in blanking and punching. We have two operations. We agreed that we have two operations. We have whatever we call blanking. This is the first operation, which is a blanking. This is the second operation, which is a punching. The question is how to obtain the die diameter and the punch diameter in the planking and the punching. Relation between clearance, how to add the clearance. The question is how to add the clearance. How to add the clearance to die diameter and punch diameter, die diameter and punch diameter in a planking and punching. Please listen to me. Please listen to me carefully. This is really important and most of students confused about this one. So please give me your attention. Please listen to me, right? Blanking is create a blank. In very simple way, blanking, you create a blank. My product is a blank. So blanking is to create a blank. You agree with me? Let me say it. Blanking is to create, this is a blank. So blanking, let me also highlight here. So blanking is to create a blank. This is a blank. Or this one. This one. Okay, so blanking is to create a blank. Blanking is to create a blank. So my concern is a blank. This is my product. My concern is a blank. Listen to me carefully. In this case, in blanking, diameter of the blank is the diameter of the die. Because the blank exit from the die. Blank exit from the die. So finally, diameter of the blank, diameter of the needed blank is the diameter of the die. So diameter of the blank die diameter بيساوي or equal to diameter of the blank. So diameter of the blank equal to the die diameter. For example, if I would like to create blank with 150 millimeter diameter, 150 millimeter diameter, then die diameter 150 millimeter. يبقى die diameter equal to blank diameter. I must adjust the die diameter to 150 millimeter. So finally you can get blank diameter 150 millimeter. What about the bunch diameter? Bunch diameter equal to die diameter or blank diameter minus 2c. Why minus? Because always you must remember, always bunch diameter must be smaller than die diameter. Never make the bunch diameter bigger than die diameter, zero immediately. You can see that the bunch must get inside, then it must be smaller, right? It happened many times. Student put the bunch diameter bigger than die diameter. So be careful about that. In case of planking, you focus on the plank. A plank here is the die. A plank 150, I would like to get a plank with 150 millimeters, then die diameter must be fixed at 150 millimeters to get a plank 150 millimeters. What about the bunch? Bunch must be this 150 or the plank diameter minus 2c. The 1c here, this is another c here. You get it? This is a plank. When you're coming to the bunch here, when I said bunch, it is not like this. Bunch, I'm concerning about the hole. Just only hole. I'm not concerning about the scrap. This one scrap. Then a bunch, whenever I would like to say this is a bunching, whenever I would like to say, I would like to create a bunch hole or create a hole or bunch 100 millimeter, يعني this means that I would like to create a hole with 100 millimeter. The hole, this hole created by bunch, not by the die. Then when I would like to say I would like to bunch 100 millimeters, then the bunch, the word bunching, you be smart. Bunching is bunch, and the blanking is a blank. Always blanking is a blank, and the bunching is a bunch. When I said I would like to bunch 150 millimeter or 100 millimeter, it means that the diameter of the bunch 100 millimeters, then diameter of the hole equal to the diameter of the bunch. It must be because the bunch creates a hole. Then diameter of the Diameter of the bunch is the diameter of the hole. What about the diameter of the die? Diameter of the die bigger, always bigger. Then diameter of the die equal to the hole diameter plus 2c. Plus 2c. It must be bigger. Never, 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 never. The die diameter is smaller than the bunch diameter. Bunch diameter must be smaller. Bunch diameter must be. Any question, guys? Any question? Please don't be confused. Blanking is a blank. Bunching is a bunch. When I said blanking, know it like this. When I said blanking, then the blank diameter is the die diameter. When I said bunching, then the whole diameter is the bunch diameter. The whole diameter is a bunch diameter. The other one is always remember die bigger than bunch. Then if you have the whole diameter bunch diameter, then the die plus 2c. If you have blanking, then the bunch equal to the blank diameter minus 2c. That's it. Any question? Is it clear? Many of students confused. So if you have any question, you can ask me anytime. One more thing here, die here is, as you can see here, there are whatever we call angular clearance here. There are a clearance, so this one will exit smoothly. This clearance usually, this is a clearance. Can you see that? It is taper. There are a die clearance here. This is a straight part to the plank will exit here. Later there are a clearance here. There are an angle here, angular clearance here. To this one will exit easily and smoothly. It is between 0.25 and 1.5 degree. This is an angle to 0.25 to 1.5 degree in each side. Right. Okay. Finally, before we take an example, the force. Also, please listen to me carefully here. A force, right? What force? Shear force. Shear force. Shear force equal to shear stress. This is a shear force or force shearing force. When you do the punching or planking, you're shearing the workpiece, right? You're shearing the material. Then the force here, the bunch force, this is a bunch force. Actually, it is shearing force equal to what? Shear stress multiplied by thickness multiplied by L. What is that? This is a shear stress multiplied by area. Let me say that it is shear stress multiplied by this one is the shear area. You agree with me? Let me say shear stress multiplied by shear area. So shear force equal to shear stress multiplied by shear area. Shear area, he said that it is T multiplied by what is that mean? Let's just understand, don't just memorize, but understand. For example, please give me your attention, guys. If you're shearing this material, if you bunch here to create a hole, for example, if you bunch to create, what is the bunch force? The bunch force equal to shear stress multiplied by shear area. What is a shear area? This is a shear area which is equal to thickness. This is a thickness because here, why we said thickness? Because here you bunch here the part here. So it is equal to thickness multiplied by the L here. L is a perimeter. This is the area, perimeter multiplied by the thickness. Perimeter is this guy, which is a 2 by R. 2 by R or by D. By D is the perimeter of the circle multiplied by thickness. This actually is a shear area. You agree with me? So it is T multiplied by L. T is the thickness and L is the length of the cut. They call it is the length of the cut. So L here is the length of the cut multiplied by thickness. Actually, L here equal to 2 by R or by D, which is the perimeter multiplied by T. Okay. If we cutting, for example, something like this, not cutting circular. If the bunch is creating something like this or something like this, it is the same. T, because here bunch will bunch here the thickness, this one thickness. So T, it is thickness multiplied by L. L is this is the L, length of the cut. So this is the shear area actually. So shear area equal to L multiplied by T. L here equal to this one plus this one plus this one plus this one, which is a perimeter. So let's say that perimeter of the part multiplied by the thickness. So generally, F equal bunch force equal to S multiplied by area, and the area is the perimeter multiplied by thickness of the cut. Did you get it? In case of we don't have shear force, this is a shear force. S here is, let me say, S here is the shear strength or shear stress. So S here is the shear stress, and F is the shear force. The equivalent is a bunch force, definitely same meaning. So F here is the bunch force or shear force, definitely it is shear force. S here is the shear strength of the material. This is the shear area as described. If shear stress not available, he give me tensile stress. Then approximation, they consider that 0.7 ultimate tensile or tensile 0.7 tensile is equal to shear. So shear here is equal to 0.7 tensile stress. If you don't have shear, if it's given that tensile stress is given, then you can say that shear equal to 0.7 tensile stress. Then you can exactly almost same. So shear equivalent to 0.7 tensile stress. So it is exactly the same. Force equal to shear multiplied by TL, which is the area, and shear here could be shear directly if given, not given, given tensile, then equal to 0.7 tensile stress. Any question, guys? Any question? Okay, let's solve the, let's take an example. Let's read together and understand a round desk 150 millimeter diameter. Let's read carefully. A round desk 150 millimeter diameter is to be blanked. يعني عايزين blanket ده 150 ملم ديسك، يعني البلانك هنا 150 ملم، يعني عايزين بالعربي بنتكلم عايزين نعمل بلانكينج 150 ملم. يبقى راوند ديسك 150 ملم diameter is to be blanked from 3.2 millimeter. This is the 3.2 millimeter strap. This is a sheet 3.2 millimeter half cold rolled steel. The material half cold rolled steel whose shear strength is given. This is a shear strength. He gave me S. Determine appropriate punch and die diameter. We need to know what is the die diameter and what is the punch diameter, and then we need to know what is the blanking force. As I told you, we need to do blanking. This 150 millimeters. Then immediately, without even thinking, the die diameter 150 millimeters. Then immediately, die diameter should be same. Die diameter 150 millimeter, right? Then here, die diameter. Let me highlight. This is the die diameter 150 millimeter. Die diameter must be same. So die diameter exactly same like this guy. So this is a die diameter. We talk about die diameter. Die diameter must be same. If this guy would like to get 150 millimeter blank, die must also 150 millimeter. What about the bunch? It must be smaller. Bunch must be smaller. If this 150, this one must be smaller than 150. Smaller was what? With 2C. We need to cut to C. Then we need to obtain what is the C value. C value equal to, approach is obtained from the table, actually. The table that I showed, but we'll give you as a constant, we'll give you the approach value in an example or in a problem later. Then AC is given, then you can obtain from the table, or we can give you AC is given and thickness is 3.2. Then you multiply AC multiply by the thickness, you get C clearance equal to 0.24. Then what is a bunch diameter? Bunch diameter equal to what? Equal to 150 minus 2C, 2 clearance, C equal 0.24. Then you get the bunch diameter. This is a bunch diameter. Can you see that? Bunch diameter must be smaller than the die diameter. Right, when you get the bunch force, what is the bunch force? The bunch force here equal to STL. S here equal to what? shear stress is given, and L here is a perimeter, as I told you. Here with circular shape, so it is a perimeter, which is a pi d. Diameter is 150. Then pi d, then you get the L. This is a perimeter, and the T is a thickness 3.2. Then you multiply, you get the force. This is a bunch force, right? Any question, guys? Any question?
Part B. What's the
Part B.
perimeter?
بريمتر يعني المحيط بالعربي.
اوكي. طيب
ما كنتش معانا من شويه. احنا كنا بنتكلم في
لا
الموضوع
والله
ده.
معاك، والله معاك، بس
بص البريمتر انت بتعمل جزء دائري اهو. خلاص انت بتعمل. لا، واضح انك ما كنتش معايا، لان انا قعدت شرحت الشرح ده شرح مفصل. بس خليك معايا. بص احنا نعمل بانش، صح؟ بنعمل بانش لايه؟ سيركل، جزء سيركلر اهو. خلاص، جزء دائري. ماشي الكلام؟ فالكلام ده احنا شرحناه قبل كده، ارجع للمحاضرة هتلاقيه موجود يعني. فالبريمتر ده المحيط ده. ال اللي هو الكات لينس. ال ده اللي هو الكات لينس، اللي هو البريمتر بتاع الجزء ده. والتي اللي هو السيكنس بتاع الشيت. فده الاريا، الشير اريا. ماشي. اوكي جايز، any question؟
يا كثير دكتور.
any question؟ حد عنده سؤال؟ okay, that's it. So next is other sheet metal cutting operation. Other sheet metal cutting operation, which is the first operation in a sheet metal working, is a cut off. Cut off actually is separating. The word cut off is separating. Here, let me highlight. Cut off is to cut here. Shearing. Cut off meaning shearing. So this is a cut off. You cut here, then you separate. Then this whatever we call cut off. Another process is a parting. Parting, there are scrap. When you do parting process, it is also separating. So this is a parting. Here parting, this is a one. Here parting, when you do parting, you separating this guy and this guy. You separate, but there are scrap. There are scrap. Here cut off, no scrap. But parting, there are scrap. So this is a big difference between cut off and parting. Proofrating is, this is a proofrating, creating holes. This is a proofrating. And you see, this is a proofrating. Proofrating is creating hole. Can you see that? This is a hole. Nippling is very example like proofrating, but the hole are overlap. Overlap mean يعني ايه؟ يعني nippling ادي hole. خلاص. sorry. Like this is a hole. The other hole will be like this. Overlapped يعني. Overlapped يعني مش separate زي كده. separate كده اللي هو proofrating. Nippling يعني تعمل over hole and hole عليه and hole عليه overlapped يعني. Notching, this is the notching يا شباب. Notching يعني هي شايفين ده؟ ده notching. This is the notching. Notching to cut from the edge here. To cut here, this is the notching. To cut from the edge, notching. Semi-notching. Semi-notching, this is a semi-notching. Let me highlight. Semi-notching is this one. This is a semi-notching. إنك مش من على الحرف بقى. يعني notching إن أنت تقطع من الحرف. Semi-notching إن أنت تقطع من النص. يعني little difference ها. lancing ده زي ده. lancing إن أنت تقطع 3 direction and keep one. This is the 3 direction you cut from here and here and here, and this one is still remaining. So this part still attached, not cut. They call it lancing. Any question يا شباب؟ حد عنده سؤال؟ Alright, this is the terminology. Slitting, this is a slitting. Slitting is to cut by circular blade. using circular blade. As you can see, you cut by using circular blades. You call it slitting. Slotting, the word, this is a slitting, but slotting is to create this part in the middle. Someone said that this is semi-notching, yes, but semi-notching any shape. Here, this one rectangular, mainly rectangular. We call it slotting. Semi-notching could be anything, could be any shape, but slotting, it is kind. This one is a special case from semi-notching. Semi-notching could be anything, but slotting is rectangular shape, mainly rectangular shape. Trimming. Trimming is to remove the additional part from casting, from foraging, from any other process previously have. For example, this one, if you remember in a foraging operation, we start with this one. We do hammering the material, and hammering the material, you get extra flash. You need to cut here to get the part and get the flash and scrap. So this is the trimming. The word trimming is to cut this extra material. So this is whatever we call trimming. And finally, shaving. The word shaving is shearing operation performed with very small clearance. This guy. Someone will say that you told us we usually avoid having very small clearance, right? We usually prefer to have clearance adjusted between very big and very small, something in between 4 to 8% of the thickness. Why we have this is very special case. You will tell me that okay, force, you said force will increase and power will increase. Okay, increase, I don't care. I need to do shaving, which is very good quality, and I don't care. Normally we do like this, but in some cases I would like to achieve this case, which is very close tolerance for certain specific technical reason. Power increase, force increase, I don't care, but I would like to do this for technical reason. Normally I have to follow this one, but in some special cases probably do this one, which is a shaving, which is very small clearance, right? This one will leading us to whatever we call is a fine planking. This one will leading us to whatever we call fine planking. And fine planking, listen to me carefully, guys. In fine planking, سامعني يا باشمهندسين؟ سامعني كويس؟ In fine planking الكليرنس 1%. In fine planking, clearance is only 1%. You told me recommendation 4 to 8%. I understand. Recommendation 4 to 8%. But I would like to have no distortion. Make it fine blank, as I just said, fine blank. There are no this kind of regions that we describe, roll over and fracture and zone. I need to have a fine blank, very straight edge. I would like to obtain the plank with a straight edge. Can you see? With straight edge. Force will increase, fine. Power will increase, okay. But finally, most important thing with me is a plank. Why? For technical reason. Some technical reason in industry require whatever they call fine plank. In case of fine plank, more arrangement must be done, not as usual. What is this kind of arrangement? First, you must put pressure pad here. Previously, we didn't put pressure pad. Here, to make fine plank, you must put pressure pad here to fix this guy here. And not only pressure pad, this is the one. Pressure pad, we must apply pressure pad. Not only that, we must add a string. Can you see this guy? Can you see this one? Here and here. This is notching. We call it is a string. This string to prevent the workpiece to move. Whenever you do punching, workpiece tend to move in this direction and this direction. Then you put string here to prevent workpiece to move from to this direction and this direction. Then you can do shearing perfectly. Then we added pressure pad. You can see we add a string here. We keep clearance 1%, meaning almost same. The punch diameter smaller definitely, but a little bit very small clearance between die and punch. 1%. Not only that, but also the pressure pad. Pressure pad, you put string here. This is the pressure pad, and then he added back pressure in the opposite side. Then a bunch is coming here, and there are additional pressure here. We put pressure, back pressure, to maintain the quality of the surface here. So definitely this pressure is a bunch pressure bigger than the back pressure. Then totally this part will moving in this direction. All will moving in this direction to bunch. However, this back pressure help to maintain the plank. So we call it is a treble action. We call it is a treble action. What is a treble action? Bad pressure. This is the bad. This is the pressure bad here, or bad pressure. We added this is one action. Second action bunch. Third action is the back pressure. Three action. Definitely clearance is very small, up to 1%. In this way, they produce whatever they call is the back as a fine planking. This is a fine planking. Any question? Is it clear? Guys, clear? Right. Anyway, if you would like to ask me anytime. No problem at all. Okay. This is the end of shearing. Next is a bending operation. This is a bending operation to bend the material. When you said bending operation, we need to bend the material. In the bending operation, as you can see here, you bend the material around straight edge. Then you bend the material as you deform the material to bend the material to perform different type of bending operation in the sheet. So this is the sheet. It was initially straight, right? It was straight, and then you bend here to create this kind of angle in the sheet deformation. For many deformation, I mean, for many this type of deformation. Okay, we have here whatever we call neutral axis. This in the middle, we call it neutral axis, right? This is the external fiber. This is the internal fiber. The external fiber above the neutral axis. This is neutral axis. Above neutral axis, this subject to tensile stress. Below the neutral axis, this fiber is subject to compressive stress. So this kind of layers attached, this layer are compressed. Right. In a bending operation, when you do bend, this is a part here. It was initially straight. It was initially this guy was straight. Initially like this. It was initially like this, right? And what happened? This one bent. This one bent. So it was initially straight and bent. Then you get this guy. Right, so this is straight, and this one is bend area. This is a bend area. This area is bend, as you can see here. There are some terminologies. This one we call is a bend radius. This one is a bend radius. This is a length. This is the length of bend length. This is whatever we call bend allowance. The bending start here. Can you realize that? A bending start here. Bending start here, and bending end here. So the starting point here and end here, this kind of a length in between, we call it is the allowance, LB. This is the allowance. This is the bend angle, alpha. Alpha here is the bend angle. Bend angle is like this, and the bend angle also, it is exactly same with a straight line. If you make straight line, like this, this also alpha. Alpha is here. So this is alpha. So alpha is angle here, and also here with a straight line. So this whatever we call is a bend angle. So alpha, this is alpha bend angle. So this is the bend radius, this is the bend angle. As you can see, this is the bend length, this is the allowance, right? This is a terminology in a bending. This AB approach, this we call it is a bending allowance. This whatever we call bending allowance. This distance AB can obtained as or by using this equation. 2 by alpha. Alpha, this is alpha, right? Alpha is this one and this one, same, exactly same. So 2 by alpha divided by 360 multiplied by R. R is a radius. R is the bend radius, this one, bend radius, plus T is the thickness. This is the thickness of the sheet. KBA, they call it is a KBA is a constant. This KBA is a factor, stretch factor. KBA is a stretch factor, and there are a condition for this kind of constant, stretch factor constant. So this guy, I mean KBA, there are a condition for the KBA is constant. We call it stretch factor. If R, which is the bend radius, is smaller than 2t, which is the thickness, then this one equal to 0.33. But if R bigger than 2t or equal to 0.5, then this constant can be obtained based on that. From this equation, we can obtain the AB, which is bend allowance. Okay, let's take an example. Let's read together and understand. Let's read it together and understand. So a sheet metal plank. Sheet metal plank is to sheet metal plank. It means what is that sheet metal plank? This part is obtained from plank. I mean, let me just say, initially we have big sheet. Initially we have big sheet, and then we blank some area inside. We blank some area inside. This blanket area is this one. So it means that we blank certain area to do this deformation. So initially it was big sheet. We take certain part of the sheet blank. So we blank this area. This is a blank area. Then we use this area to do this kind of process. So a sheet metal blank, this one is a sheet metal blank, right? So a sheet metal blank, this one is to be bent. We need this sheet metal blank, we will bend. We will bend like this. We will bend here, so we will bend it become like this, right? Is bend as shown in the figure like this. So here it was initially sheet. As you can see here, it was sheet and then we bend. So it bend like this. When it bend, it become like this. The metal has definitely the dimension is there. This one 38 millimeter. This 25 millimeter. This is a thickness 3.2 millimeter. This is 120 degree. R is 4.75. This is a bend radius. And width here, width mean this one. Width is this one. The width of the sheet. Width of the sheet is this one, equal to 4.5. 4.5, right? Modulus of elasticity is given, and yield strength is given, and tensile strength is given. Determine starting blank size. What is a starting blank size? Starting blank size is this one. Width multiplied by length. Width we know, 4.5. What is the length? The question is, what is the length of the starting blank size to obtain this guy? What is the starting? The question is, what is the starting length? Width is same, no change. What is the starting length? What is the starting length? We need to blank certain area. So what is the starting length of this one? So finally you can obtain this guy. So it is, we can say starting length equal to this part, which is 38, plus this part with a 25, plus this area in the middle, which is the AB. We need to obtain AB because this 38, 25, we need to obtain AB. If we know what is the AB, then we can know what is the length. This is the question. Then in a very simple way, calculate AB. AB equal to 2 pi alpha divided by 360 R KBA multiplied by T. Alpha here is given 120. This is not alpha. Alpha is here. This alpha can be obtained as alpha is this one. This is the alpha. this is the alpha. So alpha is the 180 minus 120, because alpha equal to this alpha. Alpha here equal to this one. This 180, then 180 minus 120 get 60. Then alpha equal to 60. Alpha equal to 60 divided by 360. R radius is 4.75 plus KBA. KBA is 0.33 obtained as we described. You see what is the R and what is the T relations, then you get the constant KPA multiplied by thickness 3.2, you get AB. This is the AB. As long as that you get AB, then the length here equal to 38 plus 25 plus AB. Then you can get the length. Then initial starting size equal to length multiplied by the width. Right. I will stop here about the type of sheet metal bending. I will stop here. Next time, inshallah, I'll discuss more about this one. Let me